All right, good morning, everyone. Can everyone online hear us? Can't see them, but
yep.
Thanks, Alyssa. Okay, awesome. Well, thank you all so much for being here today to celebrate Nicole and all of her accomplishments. My name is Heather. I am a faculty member in rehabilitation medicine, and I really like to hang out with engineers. So this is an amazing opportunity to get to co-advise Nicole with Kat Steele, and I will let you introduce yourself as well. So I'm Kat Steele, mechanical engineering. So excited to be here today. Us. Okay, let's make sure we have good batteries here. Nope. There we go. There. Okay, perfect. Awesome. So you all know and love Nicole, but for anyone who is needing a little refresher on some of her accomplishments, she received her Bachelor of Science in Mechanical Engineering in 2018 and joined us from Clarkson University in New York. And previous to that, a lifelong East Coaster, right? And so we pulled her over to the Pacific Northwest for a few years. We are super excited to have you all here today for her dissertation. And we wanted to share some of the highlights of Nicole's trajectory over the last few years. And that includes a couple of notable academic accomplishments. She was the recipient of the Gatzert Child Welfare Fellowship, which is a UW fellowship, as well as a National Science Foundation research fellowship awardee. So we're super, super proud of all of those accomplishments, and it really set us up to do some amazing work over the past several years. Turn it over to you. Yes, and now we always like to describe in a little bit more detail their time here at UW. And personally, I describe Nicole's time here a little bit like a merry-go-round. I spend a lot of time on the playgrounds these days, but hopefully you'll understand in a minute. So when she first arrived here, she was really excited about supporting research on pediatric rehabilitation. And she started working with our partners at Gillette Children's to understand one of the common surgeries, selective dorsal rhizotomy, which you'll learn more about today. For that work, she started off strong through her PhD and got the ESMAC, the European Society of Movement Analysis Best Paper Award, and was also the finalist for the David Winters and the Clinical Biomechanics Awards here in the US. Based on this work, she decided that she wanted to learn more about the clinical environment. And so she was lucky enough to go to Gillette Children's, our partners, for an internship. But now this is where things start turning. A month after her time there, we all kind of know what happens. The pandemic struck, and she couldn't even be sent home here to Seattle because she had been sublet her apartment. And so not only in pivoting her life and research, she had to pivot very quickly. Thankfully, with working with Heather and our other collaborators, she was able to pivot to something that she was also very passionate about, which was mobility aids and understanding the qualitative and lived experiences of individuals using these devices. And thankfully, that is also something that can be done from Zoom from anywhere. And now, based on this work, she really started to get into mobility aids and saw a lot of gaps and opportunities. And that's also around the time when the FDA approved its first mobility device, and Heather was doing some seminal studies here at UW. And so she finally was able to get back into the lab and back into the experiments and pivot back to this experimental realm to round out her PhD. I loved how Momona's quote, where she has said, "I've been so impressed with the breadth of research that Nicole has done. She has literally done everything from machine learning and modeling to human subjects research with babies to qualitative research." Now, I really see this as coming full circle, though, because I always like to peek back onto their grad school application. And in her grad school application, Nicole said, "My eventual career goal is to research new rehabilitation devices. There's constant discrepancy between what the engineers design and market and actual patient needs." And I think that you'll see that that really underlies her dissertation today. Now, she's learned a lot of other valuable skills during her time here, from stacking cups on her head, playing hide and seek, transporting devices via car and foot, and trying out exoskeletons and other exciting things. But outside the lab, she's also been a leader, and especially in Husky Adapt, our student club for accessible design and play technology. In particular, she was the lead for the toy adaptation group, where she not only figured out how to continue to get accessible switch adapted toys to our local families and clinics during the pandemic, but then also continued to train a large number of students in how to adapt toys. And to date, they've delivered over 800 toys that have been adapted and donated to the local community. Now, like we said, we did pull her to the Northwest, and she has taken full advantage of every multimodal mobility option available while she's been here. And so she's climbed mountains with most of you, I think, probably in this room. One other item that you guys may not have known is that she has also taken to the ice and is quite the fierce competitor. And so we also have enjoyed watching Nicole on the ice during our time here, and I still find it quite intimidating as a non-contact sports person. But through and through, I think we've seen that Nicole has been a team player, and as Michael Rosenberg always liked to say, is she's tough and she cares. And I think that really rings true. So we're really excited. Nicole's next steps. This has been, I would say, a source of angst over the past couple of months for sure. But we're super excited to share that Nicole is going to be headed to Bozeman after graduation to work with the Crosscut Elite Training Program for Nordic skiing. And we're really excited because we're all going to go to Milan in 2026 for the Paralympics. And so, yeah, so what an awesome opportunity to kind of combine a little bit of biomechanics and what you love with the sport that you love. And so we're just super thrilled for you and your next steps. And it's been an awesome journey. So thank you again all for being here. And we're really excited to celebrate Nicole. So we're going to turn it over to her. Yeah. Now you guys get to hear about everything on that merry-go-round. So with that, we will turn it over to Nicole.
Thank you for that. Hard to follow. Oh, I thought it was on present. It was on AV teaching. Okay. Okay. A little bit. Okay, I'll just get started. I think it's good, Charlotte. Thank you. Okay, so to start, I would like to thank my committee for all their support throughout the last 5 years. I'm going to jump right in. So again, as Kat had mentioned, it was a merry-go-round. So my dissertation covers walking and rolling and looking at all different technology that people use to support their multimodal mobility for individuals with disabilities. So mobility is important and diverse. It provides us access to our entire lives, our community, work, school, just to name a few. And it's considered a fundamental human right. And we use different technology that's designed by engineers to support mobility, such as walkers, wheelchairs, bikes, and cars. But there's a lot of different forms. So when I'm talking about mobility, I specifically mean self-initiated mobility. This is mobility that lets an individual initiate their movement and control it. So some examples of this are walking, propelling a manual wheelchair, or controlling a power wheelchair. Being pushed in a manual wheelchair, being pushed in a stroller are not forms of self-initiated mobility, but this is a common mode of transportation for toddlers and young kids with disabilities, and they don't experience the same benefits. So what are those benefits? Well, self-initiated mobility is really important for development, including development of physical, cognitive, and sensory abilities. And prior research has shown that having access to the self-initiated mobility causes a cascade of positive effects on social skills, interaction, communication, mobility skills, obviously, problem-solving skills, and self-care. So because of this and all those developmental impacts, on-time mobility is really important. It's important because otherwise it can be a cascaded delay of development if not having access to this. So specifically when we're looking at early mobility, the literature and scientific evidence on how kids who don't use mobility aids and learn how to walk is really expansive, but we know a lot less about how kids learn how to use other modes to support their function and participation. Early self-initiated mobility is critical for development again, but there's a lack of acceptance on those early technology due to a stigma and fear that's going to interfere with other skills. So when is this on-time mobility? Well, for kids without disabilities, they typically achieve self-initiated mobility of crawling and walking around 1 year of age or earlier. Well, what about kids with disabilities? So a common example of a disability that has an onset at birth is CP, or cerebral palsy. This is a brain injury that's caused at or near the time of birth, and it's the most common motor disability in childhood. And due to the manner of brain injuries, CP is quite a heterogeneous population. So this has implications for prognosis, treatment, and mobility. I'm going to say that a lot of times today. So the diversity is categorized by gross motor functional classification scale, or GMFCS, ranging from levels 1 to level 5, where they all use different mobility aids. So 3 of the studies in my dissertation are exclusively for individuals with CP. And then that 4th study includes participants with a wide variety of disabilities, including CP. So what does that on-time mobility timeline look like for kids with CP? So there's kind of 2 groups. There's the group that might become ambulatory with support maybe, or without support, and then the group that will use mobility. But again, there's this really big gap of usually 2 or more years before they start that. So we need to be providing mobility aids at this earlier time point. So this lays the foundation then for mobility aid use across the lifespan. So kids don't just stay kids forever. And so there's a large diversity of modes that is used throughout the lifespan. Approximately 59% of people with CP use no handheld mobility device, but they might still use an AFO like the 3rd figure there. 8% use a handheld mobility device, and 33% use wheeled mobility as their primary mode. And I'm emphasizing primary mode because we use different modes of mobility in different settings. Another study found that looking at environmental factors, 29% of people who use wheel mobility, 29% of kids with CP use wheel mobility indoors, while 41% use wheel mobility outdoors. So that setting of home, school, and outdoors impacts what type of devices we use. So I just want you to keep in mind some 3 key points as I walk you through my dissertation. Mobility is diverse and important, and early access or on-time mobility is critical for development. And we can have technology that can support this mobility. So today I'll be discussing mobility from a few different perspectives. Some individuals might walk without any mobility aids like my AIM-1. Some might use AFOs or walkers like my AIM-2, and some might use power mobility like my AIM-3. So my dissertation, as Kat highlighted before, leverages a wide variety of methods, a mixed methods approach to evaluate technology to support mobility in many forms. So my first aim is a retrospective analysis investigating elevated energy consumption during walking. My second aim is comprised of 2 qualitative and mixed method studies, understanding the lived experiences of key stakeholders on specific mobility aids. And then my third aim is an experimental study investigating the impact of different postures on power mobility for toddlers. So now jumping into that first aim and first mobility mode, walking. My first aim looks at elevated energy consumption during walking. So one of the most common complaints of families and individuals with CP is fatigue. And additionally, focus groups of individuals with CP, when they asked about what they want their research prioritized on, one of them was reducing energy. It makes sense that fatigue is such a prominent complaint and priority because they use 2 times the amount of energy consumption as their peers to walk. And so this elevated energy consumption impacts fatigue, it reduces endurance, and is a major barrier to mobility. So what causes this elevated energy consumption? So spasticity is commonly thought to contribute to this high energy. This is a muscle parameter that is the velocity-dependent resistance to stretch. So this is where my dissertation starts. I started my dissertation examining a surgery that reduces spasticity and is commonly advertised to patients and parents that after the surgery, the child will use less energy and improve their mobility overall, basing off of that theory that spasticity is what's causing high energy. The surgery is really invasive and requires a really long inpatient and outpatient PT program. Additionally, the timing of these surgeries is relatively early from when the parents first find out the diagnosis, as early as 4 years old. So they're still new to a lot of it. So what is an SDR, or a selective dorsal rhizotomy? It's a neurosurgery in which the dorsal or sensory nerve rootlets are cut to treat spasticity. So previous work has shown that spasticity significantly decreased after SDR. And since it's been theorized that spasticity is the culprit of this elevated energy consumption, our hypothesis was that if spasticity significantly contributes to that elevated energy during gait, then energy consumption should also be reduced after SDR. So we performed a retrospective study with children with spastic diplegic CP who either underwent a bilateral SDR or not. And this was critical because previous studies had looked at energy consumption after SDR, but they didn't include a control group. And other studies had also shown that there's a change in energy consumption levels over age and development. So we need to control for that. So for matching, we use baseline energy consumption, age, and spasticity. And for spasticity, we use the summary Ashford score from 6 different muscles. So these 3 parameters were transformed using an autoencoder to provide a single summary score for each participant. Then we use k-nearest neighbors to find the closest matching peer who met that RCP inclusion criteria. And then we selected that individual who did not undergo the SDR, but matched on all of those parameters. We resulted in these 2 groups. Again, you can see the similar distributions of spasticity levels, age and energy consumption before the SDR. So change in spasticity is on the x-axis, and change in energy consumption is on the y-axis. The blue circles are the SDR group, and the black triangles are the no SDR group. Now, I don't expect you to understand what this means, so we're going to simplify it. So the SDR group has significantly greater reduction in spasticity, and this confirms this portion of the hypothesis. However, this did not correlate to a reduction in energy consumption, and there was no difference in the change in energy consumption between the 2 groups. So to repeat that, spasticity was significantly reduced after SDR, but energy consumption was not significantly reduced compared to their matched CP peers. So my main contributions from this work is that spasticity is not a primary mechanistic contributor to that elevated energy consumption in CP. It also highlights the need that we really need to have these properly matched control groups of people with CP when doing research, especially when they're still aging and developing to account for those changes. And finally, the previously held clinical beliefs of the benefits of this invasive surgery need to be reevaluated. So what's happened in the last 3 years since I published this work? So this first screenshot was of Gillette Children's website 1 year ago. I'm not just calling them out, don't worry. This is what their website looks like now. They no longer advertise decreased energy consumption as a benefit on their website. Further, I can find no other US hospital that lists reduction in energy consumption as a benefit of SDR on their websites. Only the NHS in the UK and a hospital in Canada do. So while these changes are occurring on the websites from an external view, we need to make sure that we're clearly communicating to families what and if any benefits there are of these invasive surgeries outside of just reducing spasticity. So we've seen that surgical interventions are not reducing energetic costs to support mobility. So for my second aim, I sought to investigate other devices that are used to support mobility. And this includes orthoses and walkers. So this aim turns to individuals with lived experiences for their perspectives on the different mobility aids. So to start, we're going to talk about AFOs. So AFOs are ankle foot orthoses, and they are shown on the figure on the right. And these have been shown to improve walking speed, energy consumption, again, that word, gait kinematics, step length, and standing postural control for individuals with CP. And 62% of users say that they use them regularly and they're satisfied with their function, while 35% of users are not satisfied with their AFO. So why are they not satisfied? Well, clinicians in Canada had highlighted the challenges with funding and communication and technology. And then a study in Brazil with mothers of children with CP found that they wanted more personalization and increased comfort from AFOs. And now looking at the early access to mobility, since we know that the timing of the self-initiated mobility is so important. So looking at that decision-making process of that 44% of clinicians reported that not all children who need mobility aids have received them by the age of 3. My internet just dropped, but hopefully we're good. Everyone online good? Okay. Exciting. So what are those gaps besides the internet of mobility aids? Limited understanding of AFO provision process, even though they're used a lot. We don't really know what's going on, especially from individuals who use them themselves. And then looking at that early access of mobility aids. We don't know, this age group is often not included in these studies and they often focus more just on the decision-making process and not on the parent side of things. So this highlights the need for more qualitative research in this area. So to address these gaps, I conducted 2 qualitative studies to evaluate mobility aid provision. AFO study is going to be on the left in tan, and then the first mobility aid study is going to be on the right in blue. And I'm going to walk through these studies side by side to compare and contrast the differences. So this first study was a focus group study on the acquisition and use of ankle-foot orthoses across the lifespan with caregivers and users. And this first mobility aid study included surveys and interviews looking at that first mobility aid provision, and this was from the perspective of caregivers and clinicians. So the purpose of the AFO study was to really better understand the access, use, and priorities for caregivers and AFO users. We specifically focused on the perceived purpose, provision process, barriers and facilitators to use, ideas for future design, and implementation across the lifespan. And then for the first mobility aid study, we really want to understand those first experiences where they don't have any prior knowledge with previous devices, since we noticed that a lot in the other study. And then specifically, we were focusing on the prescription process, considerations, age, and all of that process, initial expectations and use patterns, and then short and long-term impacts of the first mobility aids. So the AFO study included 19 focus groups in 4 large metropolitan cities, and the quotes specific to discussions of AFOs or braces were separated for analysis. So this analysis actually includes 50 caregivers and 16 individuals with CP. We completed independent inductive coding and then established themes through discussion. And then for the first mobility aid study, this was on parents and clinicians, and it consisted of a SMART survey and REDCap, so they only answered questions relative to the knowledge and experiences they had, and this included multiple choice, Likert scales, and short answer. Additionally, there was an optional semi-structured interview that we conducted via Zoom. So 29 clinicians and 10 caregivers completed the survey, and 7 clinicians and 5 caregivers completed the interviews. Again, content analysis was conducted for the surveys, and inductive coding was conducted for the interviews. With discussion to establish themes again. So now both studies had some similar and different themes. And so I'm going to go through these side by side. First, we're going to go through some of the similar ones. So they both had a similar theme addressing the barriers and duration of provision of mobility aids. From the first mobility aid study, we found that time to delivery was pretty long, up to 6 to 9 months, depending on device, and they were quite variable. Some specific barriers that they noted were insurance, cost, paperwork, and non-cohesive care teams with poor communication within the care team. But they also discussed some solutions. This included lending libraries, which works well for walkers, but not for orthoses, and more collaboration between clinicians. And one clinician said that they started doing a joint appointment with a PT and orthotist when prescribing an orthoses. So what did we learn? This is the timeline of when a child is receiving their first mobility aid. AFOs were on average 20 months, and walkers were on average 29 months. But again, their peers are starting to walk around 12 months, and some of them are not getting any device until after they are over 3. So then going back to that same theme from the AFO study, and this included that there are multiple appointments, many delays and adjustment issues throughout the AFO provision process, and one caregiver mentioned that they had to go through a few orthotists until they found a good one. And so now the second theme was also similar, and this was highlighting the need for a lot more education and training to caregivers and users. So in the AFO study, individuals with CP and their caregivers really wanted more information, specifically on understanding why certain decisions were being made. So they want to be more part of that decision-making process. This ranged from feeling like they were given an AFO with no education, or they were being experimented on with new changes every single time they got a device and not knowing why, and then just telling them they were done. And then on the first mobility aid side, this was even amplified. They had no prior knowledge of these devices, and this was their first exposure. But only half of the parents actually received training on the devices. And this training varied in formats, and the content typically included setup, use, adjustment, maintenance, and safety, and not necessarily the education on why those devices were getting prescribed. One parent did not know they were supposed to put socks on under the AFO until the child got their second device. If nobody knows, you're supposed to wear socks under them. So now this is where the themes diverge. So first we're going to go over the final two themes from the AFO study. So this was looking at AFOs were uncomfortable and difficult to use. So they were hot, heavy. They're difficult to find shoes that work with AFOs. They're hard to put on and off, quoting a parent, like a monster, and they're not aesthetically pleasing. And then the final theme from the AFO study is a little bit more positive and talks about how despite all these challenges, they really see that AFOs can benefit mobility and independence. So this shows that they recognize that they are facilitating meaningful participation across environments, contexts, despite all the struggles that they deal with. One caregiver noted that the child can walk a further distance with the device. So this suggests that we need to keep improving the process and devices since AFOs are needed and they're still wanting to use them. They just acknowledge that they're not great. So to summarize this theme, I'm going to use an example quote from one caregiver that said it perfectly. Process is difficult, expensive, and cumbersome. But if all this technology went away, the child would not be able to participate, experience life the way he does, and they have enabled a lot. So now going back to the first mobility aid study and looking at those two final themes, we're going to start off with that clinician consistency, knowledge, and connection all impact care. So there were a lot of different prescription considerations, and some were similar and some were not. For orthoses, they considered range of motion, alignment, function, insurance, tone, and control. One of these has nothing to do with the child. And then first walker and gait trainer, they considered function, stability, control, strength, diagnosis, and skill. But then there are also considerations for the prescription that don't have to do with the child's mobility and their goals. Like this clinician saying that if they don't think the family has the bandwidth for the device, even though the child would really benefit from it, they won't bring it up. In this scenario, the PT is acting as a gatekeeper of knowledge and not educating the family to then allow them to make the decision of maybe they don't have the bandwidth and they don't want to do it, but that was their decision to make. So how satisfied are clinicians? Generally not. But looking at some positives, they were generally satisfied with the training provided with parents, which parents don't agree on, and sizing of the devices. They were not satisfied with a lot. Shoes and shoe modifications, specifically for orthoses, the training that they provide to the child, insurance coverage, how long it takes to get the device, and then the availability to try devices. And then they were pretty evenly split on the current prescription process, which kind of makes sense by the rest of these, and the parent understanding of the purpose of the device. So now this final theme was that looking at the mixed impacts and use patterns of first mobility aids. So from a caregiver perspective, walking and standing were positively impacted by AFOs, while play and pain both had mixed impacts across participants. And then for walkers, they had positive impacts on play, standing, walking, and running, and they had no impact on climbing or pain. And in the interviews, the parents did comment on the accessibility challenges related to walkers, such as damage to walls, fitting in a car, and finding good surfaces that the child can use them on. So now looking at the same questions from a clinician's perspective. AFOs positively impacted skeletal alignment, bone development, and standing, as well as walking. And they negatively impacted jumping, climbing, and running. And it was mixed for play. And this was supported by the interviews about AFOs impacting that floor to standing transition, as well as crawling, which is play for these kids. And then looking at walkers, overall, they had a much more positive opinions of them, except in regards to stair climbing and climbing, which makes sense, they have wheels. And then jumping and running were variable, but again, like still pretty positive or no impact. So that was a lot. So from the AFO study, these perceptions really highlight opportunities for improving AFO design, acquisition, and use that can support mobility and participation. And then for the first mobility study, we really saw that there's a lot of opportunities to improve education, training, and provision process timeline. So some specific takeaways are that we need to fill this knowledge gap between caregivers, users, and clinicians for AFOs. And then through design, we can reduce the length of the provision process, comfort, and ease of use of the devices themselves. And then for the first mobility aid study, specifically improving the education for both clinicians to decrease the gaps in care and the large differences we saw, and education to caregivers to then improve that care and that understanding and knowledge. And then again, continue to push for earlier provision of mobility aids to help close this self-initiated mobility gap. And maybe they were prescribing them earlier, but when it takes 9 months to get something, it really pushes it out. So my contributions from this work are that lived experiences of individuals with CP and their caregivers can inform AFO design and improvement. And when we demonstrated that individuals with CP and their caregivers want more information and understanding and clarity during that provision process. And then for first mobility aids, we demonstrated that families require much more enriched education and training on use, safety, and care for those first mobility aids. And it provides researchers and clinicians an understanding of what that current status is on prescription of first mobility aids. And the people with lived experiences themselves were able to provide suggestions for improvement of both the process and devices. So that work focused on orthoses and walkers, but now we're going to transition to another mode of mobility, powered mobility. So what about kids who are not exploring their environment yet and may benefit from power mobility at a young age? Again, here is my favorite timeline that you guys are probably tired of kids of that mobility gap. So this third aim is investigating the implementation of power mobility at 1 to 3 years of age to help offset this current self-initiated mobility gap that we have. So there's, again, stigma and fear that power mobility will interfere with other skills, which then restricts access. So when these kids have fewer opportunities to engage in age-appropriate exploration and play, then leads to the potential to have decreased motivation and passive peer interactions. So what power mobility options are there for toddlers? There are some commercial options specifically for this age group, but they're not available in the US. It's the WYSIBUG and the Bugsy. There's the ad hoc solutions of modified ride-on-toy cars or the Go Baby Go program, which are available for this age group, but rely on community adherence to making these. Then for commercial options in the US, there's pediatric power chair, which is not typically prescribed until the child's going to school and weighs 250 pounds for a toddler. And then there's the Explore Mini, which just came out in 2020 and is approved for this age group. So Go Baby Go and others have really laid the groundwork for this research. They have shown improved participation and parallel play with their peers, and also shown feasibility for as young as 6 months. But there's some limitations with these devices. They're a great solution right now because that's all we have, but they're not meant to be permanent solutions or substitute for commercially available devices. They have big limitations such as limited steering abilities and a really large turning radius, which makes them almost impossible to use inside. So then this limits their independence and reduces the amount of self-initiated movement that they actually have. So now looking at the Cromobile Explorer Mini, it's a power mobility device that's specifically designed for this age group of 1 to 3 year olds. And this device offers more independent control because of a few things: directional steering, proportional speed control, multiple speed options, and it has a really small turning radius. You can parallel park it in a closet very well. Weird skill I have gained. And then one unique feature available of the Explorer Mini is the ability to be used in both a seated and standing posture. So now you're all looking at me, why do we care about the modularity of this device? Well, this option has been theorized by both clinicians and researchers that it might allow a child to simultaneously work on their body structure and their function goals. This might include like the development of muscle activation and coordination, balance, head and trunk stability, or transition to ambulation if they're on that timeline. And a previous study with a Go Baby Go car showed that a device that activated when a child stands, the child participated in less solitary play and had more peer interaction compared to using his forearm crutches. And this study really demonstrates the feasibility of using standing power mobility for this age group. So the goal of this research was to quantify how toddlers use power mobility in different postures, both how they navigate and interact with it. Specifically, I wanted to know, how does posture impact device interaction interaction and navigation? Oh, never mind. And how does posture impact neuromechanics during paramobility use? So I hypothesized that toddlers will have less device interaction and navigation in the Explore Mini in a standing posture compared to seated, and I will be using joystick activations and distance traveled to measure this. And then for the second question, I hypothesized that toddlers will use greater muscle activity to support more weight through their legs when they're in a standing posture compared to a seated posture. And again, I'll use body weight support and muscle activity to quantify this. So this was part of a larger study where toddlers attended 12 play sessions in the Explore Mini, but I'm going to be just looking at the first 4 play visits, which had this structure. They had a play session 1, break, and a second play session, and each time they were in a different posture. So it might have been sit, break, stand, or stand, break, sit, and this was randomized each time. The sessions were child-led and guided by the Assessment of Learning Power Mobility Tool, or ALP. So to keep it consistent across kids and play sessions, we guided our interaction by their ALP level with facilitating strategies and guidelines for introducing power mobility to infants and toddlers. So we have a small enriched play environment set up in our motion capture space. We tried to make it look as fun as it could. And these play sessions were really open-ended and designed to allow the child to explore. They lasted between 15 and 20 minutes long, depending on the child's mood, energy, and interest each day. And I'm just talking more on the slide so you can all watch this really cute video. So in order to collect these measures, we collaborated with Lucy through their Sandbox program to instrument our Explore Mini with sensors. We went to Lucy to develop this custom sensor suite. We're able to measure joystick activations from custom sensing. We get distance traveled, speed, and acceleration from encoders on the wheels. And then we get body weight support and loading through load cells in the base. Additionally, we placed surface EMG or electromyography on 4 muscles on their lower limbs bilaterally. So this is what the postures look like. The saddle seat was left in place for both seated and standing trials, but we adjusted the height of the tray and the seat to change the knee angle of the device. One participant was able to stand without support of the saddle, so they completed 1/5 session without the saddle in place, as shown on the right, and I'll go through their results at the end. So 9 toddlers and their parents participated in the study. They had a range of disabilities, including orthopedic, neurological conditions, and cerebral palsy. Their mobility at the start of the study ranged from rolling, sitting, cruising, and just starting to take steps. Let's see if stopping and starting or fixes the subtitle. Okay. So first, I'm going to start off with device interaction and those navigation outcome measures to answer that first question. So this looks really pretty. What is it? To orient you with the figure on the right, you can see that it is the joystick workspace. Up is forward, down is backwards, and then left and right. And so you can see that all participants were able to interact with the joystick, but they used different methods. The top participant went to the edge of the joystick and would move along the limit of the joystick space. The second participant left nothing unexplored, except for that one session in visit 3. I don't know what's going on with that. He's a toddler. The third participant stayed much more midline, barely went to the edge and stayed much more close to that center. And then this fourth participant, I want to highlight their no saddle posture. So this is when we took that saddle seat out of support. Their navigation changed. They no longer went to the edge of the joystick and they stayed much more centralized in this posture. So while this looks really pretty, what does it mean besides just really cool art? We can segment this into different segments. So again, it's the same joystick directions. With on the right, you can see I split it into 6 different quadrants, not quadrants because there's 6 of them, but 6 different segments. And so we quantified the amount of time that they spent in each of those segments. So just taking P2, for example, they started exploring all directions. By visit 4, they were going straight, a little bit of steering, and backing up because toddlers like walls and you have to get away from them. So we did this for all participants. 4 participants, their most common direction was backward, and 5, their most common direction was forward. So of the 6 directions, they only chose 2. And it's important to note that all of the kids with CP were in the backwards group. So this is most likely due to motor control abilities and not the intended direction that they wish to drive. So now looking further into those joystick activations, where an activation is anytime the joystick is moved away from neutral and then until it's released back to neutral. To orient you with this figure, each participant has their own column, and the open circles are sit and the closed circles are stand. On average, participants had 718 activations a session, but they had more activations in the standing posture except for these two participants. On average, participants' longest joystick activation each session was about 40 seconds. But as you can see, this ranged anywhere from 3 seconds to 266 seconds, with those really long ones relating to lots of spinning and perfectly avoiding all obstacles so they didn't have to stop. But how long were most of their activations? Those were just the top. So 94% of their activations were short bursts of less than 1 second, with 3% longer than 2 seconds and only 1% longer than 5 seconds. So we know how the children are interacting with the device and the joystick, but the purpose of these devices is so they can explore their space. So how does this translate to their navigation? So overall, participants drove shorter distances in the standing posture compared to the seated posture, on average 27.5 in seated and 25.8 standing. But again, this ranged because it's toddlers with a wide variety of disabilities from anywhere from 1 meter a session to 98 meters a session. But this is the total distance traveled for each session. So we normalize this to the total time that each play session was, since this varied. But again, the relationship continues. When we look at normalized distance, it is still less in stand. So now I'm going to transition to those device interaction metrics to the neuromechanics and user metrics with the second question. So first, looking at body weight support through their legs. This figure is showing the amount of time that a participant is putting weight through their legs. And on average, participants spent more time in seated than standing. But this was variable by participant. P1 and 2 spent a lot of time supporting their body weight through their legs, and P4 and 5 were much more middle range, and then the rest were much lower. Now let's look at our outlier, P6. They were really small, and so due to the width of the saddle seat, they were unable to put barely any body weight through their legs because the seat was so wide. So the device design does impact how much weight they can put through their legs. So in summary, yes, the numbers are really low, but practically speaking, they are putting some weight through their legs. They are loading their legs, even if it's for 3 minutes. They would not be doing this in a traditional wheelchair or in a chair because of the way the saddle seat is. They're able to put weight through their legs. So now another metric to answer the second question is looking at muscle activity. So for muscle activity, we're using their mean muscle activity that was normalized to the 95th percentile that day. But muscle activity between postures was really similar. Technically, stand was slightly higher, but it was really similar. So we wanted to look a little deeper. So we looked at their muscle activity when they were playing in the EM or the Explore Mini stationary versus when they were driving around and moving with the Explore Mini. And so a positive value on this figure means that they had more muscle activity when they were driving. And you can see they do. When they are driving, their muscles are more active, especially for standing. And we suspect that this means that they're stabilizing their bodies during driving. So as you just saw with the loading data, there's not really a big difference between sit and stand, and that's likely because the saddle seat was in place. So they weren't really supporting much. So one participant was able to stand without support of the saddle. So this is one little case study just to show these results. So to orient you with this figure, the regular or the gray on the left is the average of their first 4 visits that everybody else completed. And then on the right, that's that 5th session where they had the no saddle on the dark purple. So in unsupported standing, they had less activations. They drove a shorter distance. They spent much more time loading their legs, which is good. And they had an increase specifically in their quad activation. So coming back to my hypotheses. So my first hypothesis was half correct. They did travel less distance in standing, but they also had more activations in standing. And then for my second hypothesis, the answer is much less clear. The body weight support was really similar between postures, slightly greater in sit. And the muscle activity was similar, except when they were actively driving, then stand was greater than sit. So the device is modular. So that doesn't mean that there needs to be a clear-cut answer of only use this posture, only use this posture. We're able to have nuance to it. So for example, what's the goal of the session? Is the goal to get benefits of the exploration of space and all the developmental impacts that come from that? Then leave the saddle in and do what's best for the child, whether it's sit or stand with the saddle seat. If the goal is to work on unsupported standing and muscle activation, then consider removing the saddle seat altogether if the child's able to do that. But this is nuanced. There's a lot of extra pieces to this because we know that muscle activation was higher when they were actively driving. So we want to put them in a position that they can interact and use the joystick and make sure that we're not just using it as a standard that can move that's not actually moving. So in conclusion, participants were able to interact with the joystick no matter the timeline that they were on. We had kids who will use power mobility long-term, and we had kids who will walk or who are already starting to. And again, understanding and quantifying how kids with disabilities learn to move using such technology is key to improving access to on-time mobility experience. And we showed that 15-minute bouts were still led to learning. So the contributions of this work are we the first to empirically quantify how toddlers use and interact with power mobility. We demonstrated the impact of posture on navigation and neuromechanics of power mobility use. We're able to provide some insight for clinical practice on posture selection for on-time power mobility. So in summary, my dissertation used mixed methods to holistically investigate technology that supports mobility in all forms for people with disabilities. And this work has resulted in 4 publications. 2 still that need to be submitted. And I would like to summarize the contributions of my work. So in my first aim, I discovered that FDR does not reduce energy consumption, changing our understanding of what causes that, and also the benefits of a really invasive surgery. Additionally, the study emphasized the extreme importance of including properly masked control groups for CP research, especially during aging and development. In my second aim, I established that the clinician, user, and parent perspectives on the design and provision of mobility aids, specifically AFOs and walkers. This work can lead to the prioritization of certain design improvements and improved education for both clinicians and caregivers. And then in my third aim, I quantified the impact of posture on navigation and neuromechanics of power mobility use, and that kids with a variety of disabilities were able to interact and use power mobility. Both of these outcomes can inform how on-time power mobility can be prescribed and given to toddlers with disabilities. So where do I think are some exciting spaces we can go? Well, I think we can optimize, how can we optimize self-initiated exploration for kids with disabilities? Are there certain devices that work better for certain kids? And then if you haven't guessed it from my aim 2, we really need to advance the implementation of patient and family education. Can we develop an education guide with the assistance from these stakeholders, and how can this be implemented? What do clinicians think of it, and is it feasible? And then finally, advancing the teaching of and access to power mobility use for children with disabilities. Since kids currently are denied power mobility since they don't have the skills, is there a way that we can teach them? Does the environment and exposure impact their learning so that they can get access in this very broken system? So here's my vision. We all know that self-initiated mobility is critical to development. And we know that there's currently a really big gap due to this wait and see approach. So we should be providing a variety of technology to allow for mobility in different postures, different environments, and different needs. Since mobility is user, environment, and device specific. And at these young ages, we don't really know what their mobility is going to be. We don't know what that trajectory they're on. So let's support mobility in all forms earlier so the kids can grow and discover, use the technology to support their mobility so there is no more gap. So as an example, this is what multimodal mobility looks like for me. Different modes for different environments and different needs, since mobility is about efficiency. So I'd like to thank my lab members, both past and present, my family, my husband, Mike, for supporting me through all the highs and lows of getting my PhD, adaptive sports communities for keeping me sane, allowing for an outlet, and then my collaborators at Lucy, Gillette, Seattle Children's, and Shirley Ryan Ability Lab. And finally, I would like to thank my co-advisors for their guidance, mentorship, and supporting me with the many turns and merry-go-rounds of my PhD. I will now take any questions.
All right, thank you, everyone. We will now open it up to audience questions. We will have the closed door committee session. So if you're online or in the room, you can raise your hand and we will call on you. Question. Mackenzie, you might have to repeat your question.
Hey, this is Christy. I'm going to hop in.
Hey, Christy, someone else is asking a question. I'll get to you next, okay?
Okay, great. Can't hear him.
Can you repeat the end? Sorry. Yeah, so the question was about, for that case studies, if they came back, do I think I would see changes with that no saddle standing? One interesting, I think yes, but they're also toddlers, so they got a little bit confused. As you could see, I don't know if any of you guys noticed, the amount that they were loading in that seated session in that same visit was also higher. So they did standing without the saddle first, and then they did sit with the saddle. And in that sit, when they wanted to do a big push forward, they would stand up to activate the joystick. So I think the cause and effect might have been a little bit confused, but we're excited for it. So I think it would have helped. He did need reminders to like stand up a few times. He would like drop into a really deep squat thinking that the saddle was there and it wasn't there. So I think he could learn over time, but again, I don't think doing just standing without the saddle is the way to go for him, because having access to that mobility and easier access to the joystick, because he was like leaning back on the tray and also like supporting his weight through his arms, which is why I think his joystick interaction really changed. Okay, I'm going to take Christy's question. You can unmute now.
Awesome. Can you hear me?
Yes.
First of all, congratulations. Exciting, very wide-reaching work across many functional levels. It's so exciting. I just wanted my comment, actually, I put it into the chat. Your documentation of those really short bursts of interaction with the joystick as the kids were given mobility with the devices you were testing in the movement lab, that's totally consistent what we've seen in the literature for physical activity for typically developing toddlers, for walking and for physical activity. So it would be interesting to maybe cross-reference that when you write up your papers or whatever, because so they're behaving, their mobility behaviors, those short bursts are hypothesized that mass practice getting in 14,000 steps a day as an emerging walker would be comparable to the quick short bursts of walking, short bursts of physical activity that you see in typically developing kids. So they're showing us the same kind of developmental trajectory, but with the accommodations that you're offering them. So I just wanted to add that comment. Basically, it's not a question, it's just a comment, an observation.
Yeah, I will comment on that question or comment. I think one thing that I did see was that typically most of them were under a minute, but there were some longer in that prior literature, where only like 3 of our kids ever got an activation longer than a minute. So I think maybe in the earlier bouts, I'm curious what Kim finds with the longer study with when they had 12 sessions, did they have more of those longer bouts or not? But in the first 4 sessions, it was still a really short amount of time.
Totally makes sense, because emerging walkers stand up, fall in space, take a step, fall down, stand up, fall in space, take 2 steps, fall down. So, but then there's a learning curve, right? And that what is the trajectory for the kids with motor impairment versus kids who are typically developing? But it makes sense. You're right. I will be curious to see what the longer training sessions find out. But yes, thanks.
Thank you.
I think you do a great job. Okay, I have a lot of questions, but I'm just going to start with one. So for the child that was really small in your final study, where the saddle was perhaps too big for them to realize, do you think that adjusting the saddle size, although if you could adjust the extremity, do you think adjusting the saddle size for certain kids would help them kind of do a mix stand?
Yeah, and so I think there's 2 different options here. Like the saddle seat serves as a seat for some kids, but then there's other like devices like gait trainers that have more of like a banana. It's less wide. It's still like a saddle seat. I don't know the exact word. Maybe Heather knows the exact word. But it's less wide and more like supports them. Or there are even some that have like harness straps that like it's like a mesh kind of seat that like they can rest into, but it's not going to like, it's not like a seat. So I think that could help. But yeah, she was a very small participant, so she was the one that we had the hardest time fitting nicely into the device. Oh, sorry. Thank you, Elijah.
So I'm curious if you thought about or other views of the age. So you mentioned that kids, you mostly drove backwards. Could you convert that kid only while they're exploring, could you change controls so you're then forcing?
Yeah, so there's a few different, are you still writing the question? Okay, so I'll just go ahead. There's a few different ways you can do this. There's also I'll answer this in two parts. One, yes, you can change direction of the joystick control. I actually learned this at a wheelchair conference like a month ago. But you can change the direction, you can restrict regions, you can rotate, like if forward is like going to be slightly to the left, which one of our participants definitely could have benefited from, where forward for them was slightly to the left, so they were always doing like a arc. So there is that option, but I don't know how it would be best implemented. I think it'd be like picking one and using it for a few sessions so that you're not confusing the child of like the cause and effect. You don't want to like not ruin, but like bring back their learning phases. And then on the other side, there's also been studies with how to like make toddlers go in like a half an H format of like go straight, take a right turn, and go straight and then take a left turn. And they use like a resistance. So like the joystick wouldn't go in that direction. And they did training on that. And then they took off the resistance and then went in that path. And they were able to navigate after. So it was more of like training them to still move in that same direction, but guiding them in like through the learning process without having to like have hands on the joystick. Because you want to try to limit how much you're interacting with the device because that is their device. So we try to be verbal if we're going to touch the joystick, and usually it's for safety reasons. Charlotte?
Yeah, I have a question about being too, slightly different, also great job. We mentioned a couple times that clinician parents had more trained child about the bikes. I think it's a great idea, but I also was curious how you train 2-year-olds. Yeah, it goes. I don't know if anyone mentioned it.
Yeah. So I don't think the parents were necessarily asking for more training for the child, but I think it's like age dependent. So maybe it's like eventually like working on like doing the straps themselves or things like that, or explaining in however a toddler can comprehend, like, oh, this is going to help you walk, or it's going to help you stand, or like showing it on a teddy bear, for example, like as an example. And then like as they age, helping with that, because there were in the AFO study, there were some kids who like it was their big goal in high school to be able to put on their AFOs and shoes by themselves. And because it's such a difficult process, that was a really hard skill for them to attain. And so I think that's where like that education piece comes from. Also, it might be of like if a kid gets their AFOs for the first time when they're 2 and then like always keep having them, making sure that the clinician is educating them at their level every time, not just assuming like, oh, you've had these before, you know, but like you were 5 when you got them, so maybe you don't actually know, and were never educated by the clinician. Yeah, so we did do some exit interviews with some of the parents on like their perspectives, and some of them at the end of the study said like, most of them said, I did not expect my child to be this good at this. That was one part, and some of them still said like, oh, we're trying to get a manual chair, like we don't want to get a power wheelchair. So there's still that stigma, like they were okay doing the study, but like as far as like getting it in their home and using it full time, there's still some challenges with like the stigma and fear there. But I think one thing about the Explorer Mini is like it's new, it's exciting, it's bright yellow, it doesn't look like a power chair, it's much smaller. So maybe if it's used more for those early ages, but I don't know how that will transition over to like the big scary power wheelchairs, because the kids' power wheelchairs are adult ones that are shrunk down, so they're really, really big. And a lot of these families, like there's a difference on like acceptance of disability at that age point. Oh, yes. I was like, who are we talking about? Yes. So actually, one family made their own version of the Explorer Mini. They used like a little go-kart and they modified it. It had 2 levers and they modified it to use with 1 joystick. So that the child was still able to use the device and get experience and like exposure to all of that. Yeah, that was, so yes, some families are like very excited about it and are trying to use it. There's just differences in their perceptions coming in and also leaving. That family in particular also did not expect their child to be able to use power mobility at the start of the study. So that was really exciting that they're now using it in the home and have access to that.
One of your words against education. How much do you think education parents bridge the gap?
Yeah, I think we have a lot to do with education. There's a lot of ableism that families and parents have just by like how society views disability. And so I think especially with these young kids, providing some education, I don't know what setting is best for that, but teaching them about like mobility is mobility. It doesn't, like, walking's not better than rolling, and really provide like showing what they can do with the use of technology, and that technology is going to help them, not to hold them back. So yeah, there's definitely more. Okay.
Hi, Nicole. Can you hear me?
Yes.
Great work. Love seeing kind of the culmination of the last 5 years. I'm wondering, so you mentioned that the Explorer Mini is FDA approved. I'm wondering, kind of pairing that with your second aim, what kind of access issues you foresee with this device? Is it something that is reimbursable? Is it something that is being recommended in clinical environments? Or if not, how do you how can people be proactive with this new kind of FDA acceptance and regulation in making this device more available?
Yeah, I feel like every time, did everyone hear that question? Okay, every time I get that question, it like has changed since the last time I've had to answer that question. It's a constant moving battle. Some insurance companies are covering them. Some are saying yes, but then, oh, that's your power wheelchair or your wheelchair for the next 5 years, which it's not. And so there's a lot that needs to like making those lines clear and like what insurance code is put under. I see this as a great, especially since it's for such, like, they only fit in it for so long. I think that like clinics and schools and preschools should have a few Explorer Minis or one Explorer Mini that the kid's able to come in and use it to have that exposure, but not necessarily putting it on the family. So kind of like having these lending libraries for Explorer Mini so they have access to that movement, but it doesn't then, we're in a broken system. So like ideally we'd love for them to have it in their home, but if that's going to prevent them from getting a chair that they can use when they go to school or when they go to preschool later, making sure they have access to it earlier. So it's not really a clear answer. Some people are using grants to fund them. They say it's, Promobile says it's listed as a rate that is fine for parents to cover, but it's like $3,000. So yeah, it's not really.
Keep it going. Nicole, first of all, thank you so much and great job on such a breadth of work with a number of techniques. I wonder if you can talk about for your first study, the matching was really well thought out, and I appreciate that approach for matching. Were there other factors that you considered that might be relevant to matching and better understanding?
Yeah, so man, gotta think back 5 years. No, so we did consider a few other ones. We wanted to keep the variables that we were matching on low, otherwise the amount of matches we we're going to be able to get wouldn't work. But we did go back after the fact and like look at strength and walking speed, which are both kind of handled with other parameters, and made sure and like those values still match without matching on those parameters like holistically as a group. So we wanted to keep the numbers of how many we matched to a minimum so that we were able to get as many kids as we were able to get in that study.
Great. Well, in the interest of time, you all have outstanding questions.
But please join us in thanking Nicole for her wonderful presentation again. The folks on Zoom can't see it, but we even have foam fingers. here in the audience. We will now have a quick break before the closed door session. So committee members, Patrick on Zoom, don't go anywhere. Everyone else have a lovely day. If you are in Seattle, 4 p.m. at Burt Gilman Brewery to celebrate or console, we all know that Nicole. But thank you all, and take some of the snacks on your way out. Thank you everyone online.